Hi guys, today's topic is the last topic that we'll be doing in chapter 10, and we're going to talk about mathematical expectation. So the mathematical expected payoff of a random experiment is represented by E, which is mathematical, and what you're going to do is you're going to take the probability multiply by the payoff. And if there are multiple events happening, then you're going to add all the probabilities times the payoff. Sorry guys. Probability and the payoff. And you're going to add all of them up, right? So if there's like 1, 2, 3, 4 different things that could happen, you're going to take all 4 of them and then multiply it by your payoff, right? So let's take a look. The first thing you need to do is find your probability of each one, right? So we're going to find the probability of getting 10 points. Let's make sure I do this right. Probability of 5 points, probability of 2 points, and the probability of no points. So we're going to have to find the area of each of the values, right? And then divide it by your total area of the board. So this is, let's see, this is 3 here, this is 3, and this is 3. So for a total of 9, but this whole thing is 18. I'll do 2 lines for inches. So we're going to do pi r squared for area of a circle. And so we're going to take that first circle, which is the inner one, which is pi times 3 squared all over 18 squared, because 18 squared is the overall that you can do, right? So then you'll have 9 pi over 324. We can reduce that to pi over 36, which is approximately 0.087. Let's round to the nearest thousandth today. Okay. To find the probability of getting 5 points, you have to subtract or take this bigger circle with a radius of 6, so pi 6 squared, right, because it's 3 plus 3. And then we're going to subtract by the area of the 10 point, because we have to take away that spot. So we're left with a donut, not with the whole circle, right? Minus 9 pi all over 18 squared. Okay, so that's 36 pi minus 9 pi over 324. Notice I'm doing one thing each time, right? So I'm not like jumping to the very end. Okay. This reduces, you can use math fraction, to pi over 12, which is approximately, well, anytime I round I can use approximately 0.262. Okay, so let's keep going. If you are able to, at this point, figure out the probability of each of these, pause your video, go for it again. I'm just going to keep writing. Same idea, now we're taking 2, but we're going to take away the 5 points. So we're going to go pi 9 squared minus 36 pi over 18 squared so that'll be 45 pi over 324 reduces to 5 pi over 36, which is approximately 0.436. Okay, so the percentage of getting these two are much higher than getting 10 points. Now let's see what happens. If I take the whole area, subtracting the biggest circle, which is 81 pi, right, from 2 points, all over 18 squared. That's 324 minus 81 pi over 324. We cannot simplify this further because they don't all have pi's, right? You can't combine like terms. So this is approximately 0.215. Now, quick check. We do know that all of these probabilities should have some approximately 1, right? Based on rounding, it might be slightly off, but it should be approximately 1 when you add them together. Okay, so now let's find how many points do you expect to score. So we're going to take the probability of each of these, multiply by how many points you are getting in each one. So let's see. E equals, let's just use the fractions for more accurate answers. So chances of me getting my payoff for 10 points is I'm going to take pi over 36 times 10 for points. And then I'm going to add pi over 12 times 5 points, right? So there's that chance of me getting 5 points. And then I'm going to have 5 pi over 36 for 2 points. And then I do have to consider 0 points as well, right? So I'm going to have 324 minus 81 pi all over 324 times 0. But that's just gone, right? When you type this all into your calculator, you're going to get approximately 3.05. So that means you expect to score about 3 points per throw. So this next problem is exactly the same. We're just going to be given the probabilities already. So when Elaine left for college, her mom offered to reward her with further scholarship money for her grades. She agreed to pay $1,000 if Elaine received all A's, or $100 for each A that she makes. When Elaine arrived at her school, she chooses classes in which she thought she could make A's. She estimates her probabilities of making A's in English as 95%, cooking is 91%, Spanish is 99%, and PE is 82%. Calculate her mathematical expected payoff if she chooses $100 per A. Okay, so let's see. This one means that we're going to take the probability of an A in English times $100 plus her probability of an A in cooking times 100 plus probability of an A in, let's see, make sure we don't miss anything, Spanish times 100 plus probability of an A in PE times 100. So now we can just plug in our numbers. 0.95 for English times 100. I don't need to do dollar signs anymore. Plus 0.91 times 100 plus 0.99 times 100 plus 0.82 times 100. That approximately pays out to $367. Okay. So what if she chooses $1,000 for all A's? Okay, so let's think about this one now. That means for her expected payoff, she has to get all A's at the same time, which means you need to take the probability of her getting an A in English and an A in, what's the next one, cooking, and an A in Spanish, and an A in PE. And we have to take all of that, multiply by 1,000, right? So we have to figure out all of these probabilities, and the word and, hopefully you remember, means multiply. So we're going to multiply those probabilities and then times 1,000. So I'm going to have, let's see, 0. Oh, I guess I could write it out. Okay, so let me show you what I would do in case students were confused. A in English times probability of A in cooking times probability of A in Spanish times probability of A in PE times 1,000. Okay, so that equals 0.95, 0.91, 0.99, 0.82 times 1,000, which gives you an expected payoff of 701.880. Okay. So, which offer should you choose? Well, the probability of Elaine getting A's is high enough. Getting all A's is high enough that she should, with an expected payout of, of $701.80 versus $367, that she should take the $1,000 for all A's. Okay, last example. So the basketball toss at your carnival costs $2 to play. You shoot 3 balls. If you make no baskets, you win nothing, and you lose your $2, of course. Okay. If you make just 1 basket, you win $3. For every 2 baskets, you win 5, and making all 3 wins you 10. What's the probability of, the probability of making any one shot is 30%. What is your mathematical expected payoff for this game? So let's take a moment and write down what we're really looking for. We need to figure out the probability of shooting, make no baskets, right? Probability of no baskets. 3 misses. Let's write 3 misses. Times 0. This is not even times 0. This is times -2, because you have to take away the $2, right? So you get $0, but it costs you 2 to play. Okay, let's write that in. And then we're going to take the probability of make 1, make 2 misses. Excuse me. That one we get $3. Minus 2 though. Plus the probability of 2 makes and 1 miss, which is, let's see, 2 baskets is $5. Plus the probability of 3 makes, which is payoff of 10 minus 2. Oops, sorry about that. Okay, so at this point, now we just need to find the probability. Now, remember, it's not as simple as like 30% for like all 3, right? This one is 30% times 30% times 30%. This one we have to take 30% times 30% times 70%, right? So this is similar to our basketball problem or our shooting baskets problem. The other thing you have to consider is that you also need to multiply by the different ways that we can get this. Okay, remember there were lots of different ways. So need to consider your entire sample space. So what is your entire sample space? Let's do shot 1, shot 2, and shot 3. Okay, so I'm going to either make or miss the first shot. After I make it, I can make or miss my second shot, and then I can make or miss my third. So there are 6 different probable outcomes, right? So you could, let's see, we'll go in this order. Ready? We could miss 3. There's only one way for this to happen, right? Right here, 1, 2, 3. If you make 2, miss 1, there are 3 ways this can happen. Okay, so let's see, ready? 1, 2, here, we could do this one, and then we could do this one. Miss, make, make. Okay. This one, if you make only 1, miss 2, right? And if you follow these, we're going to have to make the first one and miss, so that's one way. We can miss, make, miss, that's 2, and miss, miss, make, which is 3. And then make all 3. There's only one way to make that happen. Okay. So these numbers are going to be multiplied in front of each of these. So let's take a look. We know there's one way to miss all 3. So I'm going to miss all 3, and if you're making a shot is 30%, that means miss equals 70%. Right? So I'll go 0.7, but we're going to have 3 of them. Okay. And then we're going to have, I'm actually going to write this in if you don't mind, 0.3, okay. And there's none of those. You'll see why I'm going to show you that in just a second. Okay. Then we're going to add 3. We're going to, oh, I wrote this really poorly. I'm sorry. Let's change this. Can we swap these? They end up being the same, but I just want to be consistent in the order we're going. So we're going to make none, make 1, make 2, make 3. Okay. Miss 3, miss 2, miss 1, miss 0. Okay. So then this one, let's see, I'm going to make one of them. 0. This is not organized the way I want it to. I'm so sorry. Let's think about this one. No, I like this better. Okay, so let's talk about misses first. I should have written miss. So miss, just to keep consistent with this, will be 0.7, but I'm going to miss 2 of them this time. And we're going to make 1. Plus, I have to multiply it by the 3 ways I can make 2 miss 1. So I'm going to miss 1 and make 2. And then I can have one way of missing 0 times making 3. Okay. Now the reason I wanted to write this all out is because I'm hoping that these numbers 1, 3, 3, 1 look really familiar to you. These come from Pascal's triangle. Okay, do you guys remember the triangle where you have 1 at the top and then you add 1s on the side, but then the number in the middle is like 2 because it's 1 plus 1, and then you add the 1s on the side? and then 1 plus 2 is 3, 2 plus 1 is 3, and then we add 1s. If you had 4 shots that you are taking, then we would continue Pascal's triangle to get the number of ways that we can make the combinations happen, right? Which is a lot better than drawing this out and following and hoping that you end up with the right numbers. So please keep in mind that these numbers are Pascal's triangle. And if you remember from way back when, we took misses and makes, misses makes, misses makes, misses makes, right? And what I did with this for Pascal's triangle is I took 3 for 0.7, 2, 1, and 0, and then we can go backwards, 3, 2, 1, 0. And the really cool thing is it actually doesn't matter which one you start with, right? So if you did like, if you flip-flop 0.3 here and 0.7 here, that's the same as this, right? So you could flip them in any way you want and it would be fine. So your expected payoff is 0.538. And what is that? 0.538 means that you are expected to win 54 cents overall. Let's go after paying $2 to play. Right? So this is your expected payout, which is pretty low. Okay, that completes our lesson for today, and we will practice tomorrow.